Okay, we are on air. Hello everyone, it's Tyler, and today we are going to be doing August solar observing with the Northwest Suburban Astronomers President, Bob Peace. Can you say hi, Bob?
Hello, everyone.
So today
Hi,
we are going to
Tyler.
be... What? Sorry.
I said hi, Tyler. It's good to be with you.
Yeah. So today we're going to be talking about solar observing. Even though it's cloudy here in Chicago area, we're just going to go through that. And also we're going to talk with Bob about solar observing, and he'll share some good images with you guys about that. So let's just get into a couple of questions with Bob. So Bob, when did you first become interested in astronomy?
Well, my father used to land jets by using the stars. He was a navigator in the military. And so it fascinated me a little bit, but not quite as much as when I got older. And then I bought my first telescope in 1978, and there was an announcement that the Voyager mission was going to be taking off in '79. Both of them were. And a neighbor came by and jokingly said, "You better hurry up and get one, Bob, because they're going to put condominiums on the rings." So I went out and I bought one, and bought a 4-inch reflector from the American Science Center, and it gave me the first thing I saw was Jupiter, and it was the first thing I could find.
Yeah,
but it was pretty interesting.
that's pretty cool. Yeah, so I'm just going to try to share my screen. You're sharing yours. Okay, there you go. Okay, so I'm going to show you today's live image of the solar disk. So today you can see there's a couple of sunspots. It's kind of different than the couple of last days because it's been blank. So explain what we're seeing here, Bob.
Well, if you follow this on a day-to-day basis, you'd be looking at you'd be able to pick up the rotation of the star. You're seeing very small spots. The sun is inactive at this time, and it's really, if you compare how it looks now compared to 2014, or a couple of them I can put on my screen, of much larger spots, you'd see that it's a very, very quiet time on the sun. And that's got them a little bit mysterious as to why. They think maybe perhaps the rate of fusion going on inside the sun might be at a lower level at this time, perhaps, or maybe it's even the opposite of that, at the higher, and the reaction of the upper atmospheres become this way. But it depends. It takes years and years for the information to get to us. But where the fusion rate gets to us very quickly, and by the neutrino counts. But the information you're getting up here now, that when those neutrinos were made in the solar interior, it's going to be 100,000 years before all the other information comes out, and because it takes light so much longer, it bounces around in there quite a bit.
So these are sunspots, correct? So they're cooler than the rest.
Yeah, they're small. They're small spot, small active regions, and there's not really much going on, and it's a very quiet sun.
Yeah. So the sun goes through a 11-year solar cycle, correct?
That's correct.
So right now it's in solar minimum. So could you explain the solar cycle?
Well, you got it's difficult to exactly. Sometimes it seems to match the orbit of Jupiter, but they don't know. That could be just a coincidence. They're going to find out more with the Parker Solar Probe as it goes into the atmosphere. They're testing different parts of let's say, the corona, which lies on, it's the outer atmosphere, which you can't see in this picture here, but this is from SOHO. And SOHO picks up like a lot of sound waves. inside the sun because it bangs around and it gongs like a bell, but it's at pitches we can't hear. And so they can SOHO can pick up the spots coming from the other side, and they'll be able to predict when we're going to have an active time or not. But as far as the cycle goes, I mean, it's difficult to explain why it happens. They can guess, but they're only guesses right now. And as instruments get more advanced and years go by, they're going to come up with better answers. But for right now, all you could do is make a model of it, but what you think goes on inside the sun. But eventually, the data is going to wind up changing that model.
Okay, yeah. So we're looking at these sunspots. How big can they get?
Oh, they can become enormous. If you look at that image, I can put up an image here from my files of some very large solar spots. And one is, let's see, we got it right here. That one right there, do you see that?
Yes.
That I put up, or did it show there or not?
Yes, I see it.
Yeah, well, that spot there alone is, like thousands of spots right there. And, it's like that's far more enormous than the Earth. And the ones you're looking at, I mean, much, much larger than the ones you're looking at. If I wanted to go back now and show you another spot or a picture, or let's see, even a video I might have in here. Let me see if I got some pictures of them. You can see some of these live. Let's see, that was around 2015. And I don't believe I have that one there. It might be up on the desktop. Let's take a look. They're here in videos. Yeah, it's right here. Here's one right here that's live. Can I play the video on there at all or no?
Yes, you can.
Yeah, okay. There it is, and now you'll be able to see almost like you have an active region right by it there, the whiter section. The darker sections are where there's less density. And you're seeing actually as you're moving across the solar surface, this is when it was a little bit more active time compared to now. And you're seeing filaments in the dark, long stringy areas. And the other things that look a little bit like grasses right near there are called fibrils. Out on the edge of the star, you'll see prominences that are popping off, but sometimes you can pick up the fibrils out there are given a different name. They're called spicules. Just like prominences are given a different name on the solar surface, we call them filaments. Mm-hmm. And this was a bit more active time for our star, and you can see the really nice prominence there to the right there. And it's as you keep spanning across here, you get it. There's 109 Earths that have fit across this thing. This, basically the diameters, and the sun is enormous. But it's this is the chromosphere. It's not the photosphere. What that photo you had was a picture, pretty much, of the photosphere, and this lies on top of that. And here I'm going through camera settings, readjusting it. So now you're going to be able to see what it looks like as a full disk. So you can see the camera action and work. And you can see some of the, call me here, on and then off. Now you'll see the whole disk as it looks. And you get more detail with much less magnification on any object, just like looking through an eyepiece. It looks like this. And there's so basically that's a little bit more active time. Not quite as active. One far more active than that occurred here. If you want to see what a solar flare looks like, this was in October 2014. That was enormous.
Mm-hmm.
And that was probably the biggest one they had probably in the last 30 years. Now you're seeing prominences here, and you can tell that there are areas in which there's less density. You can see almost right through it. And the spots are right here and again here. And this darkened region here is part of the material that's coming right at you. This is where the solar flare is erupting.
That thing's massive.
Yeah, that is enormous. That's an enormous flare. And that's a live video. You're not looking at a picture. That thing kept going and going for, it was going on for about 35 minutes. This is like the third video of it.
So when did this happen?
This was October 24th, 2014. And if you look that up into NASA's, they'll actually have a photo of it, and this is what it looks like in the ultraviolet at the same time. You can see actually the same shape right in here and across here. It happened on the same day. And it's a model they pretty much go back to many times. This filament right here is what they were concerned about at the same time. We could have had a Carrington event if this had been pulled at the same time that this occurred. And the corona would have just pulled this off, and then it's almost like dragging iron filings off of a table in an experiment at school when you're taking a magnet and just drawing them off, whereas a solar flare is a little bit more like hooking up a capacitor in reverse to a power supply, and then the thing whistles up and blows. What happens is the feet of these magnetic loops come up, and if one of the wrong polarity, it's like horseshoe magnets. And if one of the wrong pole gets hooked onto the wrong spot, then you get this flare up. And then it twists into like a cage and then just blows. So if the 1-2 event had occurred, we could have lost electricity in the United States back then they were estimating up to 18 months.
And that would not be good. That
would be no internet, no gas stations, nothing. It would be disaster. And it was, but a lot of times, during times like this, I have my fun by catching jets going across the solar disk. And I can give you an example. Here's one.
Well, before you get to that, so could you explain to the viewers that don't know what the Carrington event was?
1859, they had a Carrington event when a big, large flare went off at the same time as a coronal mass ejection. It happened actually one day apart, but nonetheless, the output was so powerful that it knocked out all electricity in the United States, and some of the AT&T people were knocked right off their telephone poles that they were working on. Now, we didn't have all that much back then, and it seems I've lost you.
Oh, that's weird.
Here, we can get back to you here. Let me see. Let me go to Google Hangouts. Is that you going on over there? Oh, no. That's my video doing that.
1 second. Okay, so can you hear me?
Yeah, I can hear you.
Okay, so you just keep on sharing your screen.
Okay.
Keep on talking about what you were talking about, the Carrington event.
Okay, it's knocked out electricity in the United States, but we didn't have that. We weren't as dependent on it back then. 1859, all that existed was telegraphs, and they were new. But nonetheless, you had the sun at a little bit more active time back then, and we're nowhere near that. This particular solar minimum could last quite a while, and so it's been debatable.
Okay, so do you have any other videos to show?
Oh yeah, I can show you the you know, I can give you. I don't know if you can see it or not. Can you see that?
Yes.
Okay, what you're going to see is a gentle wave. This is actually the tollway near my home, and that's actually one of the LEDs. And you're going to see a jet coming across, like right in there. And I'll catch them a lot of times like that. And there's times when I'll even catch a military jet going by. And that's and that was like in this video. And you'll see one just zoop right on down through, and it'll pop right through the screen very, very quickly. And when it gets to there. But it was very cold out at this time. It was in December, which is a good time to actually get these. And are we there yet? Come on, Buster. You should be popping through. There we go.
Yep. It's very quick.
Yeah. Yeah, but it's a lot of times. Sometimes I'll just go after a sunset, and I'll just make a video, music video of it. But the equipment I'm using usually is this telescope right here. That's a Lunt solar telescope with a Mallancam video camera. It's their signature model, which they use primarily for the sun and for planets. Mm-hmm. And this one's got a stack on it, although the stack no longer functions. I had to take it off, but it's not to worry. It works pretty well without it. But it's been my partner for a long time. I like the sun because it's dynamic and it changes from day to day to day. If I look at a lot of deep sky objects, well, they do look good, but the amount of change that's going to occur them isn't really that much. And what they can have happen to them, let's say if you look at Saturn will change because from year to year to year, it if you get a pick of Saturn, let's say like this, its rings, the tilt will change.
Yeah.
And so you can get them to get different views of it, and it does really look good. And that's with a little bit of help from the video processing. This is Mars. And that isn't recently, though, because recently it's been pretty dusty.
That's Sturgis Major in there, right?
Now, this one is M42.
No, before that.
This is, before that.
Was Sturgis
right
Major on Mars? Yeah.
Yeah.
Okay.
Yeah. There's, and then here's M42 now, the Great Orion Nebula. But it's this is just done with a video camera. It's just a screenshot. I didn't really do any processing with it. Actually, you wouldn't use a video camera for processing, and but it gives you an indication that okay, that's what it looks like last year. That's what it'll look like next year, and that's what it'll look like the year after. If you're used to seeing a lot, then you're not going to be as impressed. But if you're showing it to a public who's never seen it, they'll jump right out of their socks.
Yeah.
And so it's like let's see if I got one of Jupiter in here. I should have one. There's Mars, Saturn. Should be under the J's. Up in here somewhere. We got it. These are all videos. Oh, that's the desktop. Yes, there's Jupiter.
Okay, Bob, so I had to go do something. I'll be right back, so just keep on talking to our viewers.
Okay, thank you.
that's a nice image of Jupiter.
Yeah, that was taken with actually my 8-inch telescope, and that was it was a little farther overhead at this time, and I didn't know we had dead air there. I thought we had hung up, but nonetheless, good to have you back. And but if there's any other questions you have, be free to ask them, or if anything else you want to see.
Sure.
Then some of the research.
Go ahead.
Yeah, go ahead.
Well, I'm just going to show the current H alpha view of the sun. Should be right here. Here's the this was a couple like an hour ago, but it's from where was this? Big Bear, California.
Okay.
So you can see there's a couple of prominences along here, I guess.
Yeah, and you can see they're very small, and you can see the active regions on the solar disk it's very minimal.
Yeah. Sorry, I'm switching the screen so it'll be mine. There we go. So yeah, but you can see those active regions here, and then also there's a couple of flares on the edge. So estimating, how big do you think these flares are right here? This one.
Well, those aren't flares; those are prominences. Remember?
I meant prominences. That's what I meant. Yeah.
The prominences there. If you can fit 109 of them across a disk, you can. It looks like this one, that one you have over at around 5 o'clock, or let's see, at about 7 o'clock. Yeah, that one could easily be larger than the Earth. The others are just about the size of it. I'm trying to think if about 109 of them could fit across. Yeah, it looks like they could, but that's still small. A lot of prominences will be far many more Earths than that. Just enormous. And the few I showed you, you could see a lot of them were much bigger.
Mm-hmm. So this is actually earlier. So I wanted to show how these prominences can develop and dissipate. So this is actually from Australia about 14 hours ago. This says 13, but that was about 1 o'clock. So 5:23 UTC. So you see this prominence. Oh, wrong view. This prominence here was much larger earlier.
Yeah.
And then we had that one up here. This one was actually kind of branching out a little more, but
yeah. Well, sometimes that can also be due to the atmosphere. Seeing it's changing. They're out in California. Oh, let's see. That's in Australia.
Yes, this is Australia, and I guess it could be true too in California. They're having those wildfires, so
yeah. And Australia. I mean, it could just be a light cloud. They'll be able to punch right through a cloud pretty easily if it's a thin cloud. The cirrus clouds are perfect for solar viewing sometimes because in hydrogen alpha, because they'll actually filter out, just enough of it where you'll pick up other details you don't normally see.
Mm-hmm.
And it can give rather spectacular views a lot of times that way. I got several videos of those, but I don't think you have that much time for all of them.
Oh, we haven't. We have as much time as you want. So yeah. Also, you can see that there's movement also of the sun. You see where my mouse is right now. I think you can see that.
Yeah.
So see how it moved.
Yeah. That's very good. Very good display. Yeah, very good.
So if you'd like to see any more of these pictures, viewers, just go to halpha.nso.edu, and they have different views across the world, and that's the National Solar Observatory Synoptic Program.
Yeah, that's very, very, a lot of times you can pick up differential rotation. I've done that before in the past with a long filament going across the solar disk and then watching the thing get twisted up as it went across. So other parts were obviously moving at a much greater speed towards the equator than they were out in the polar regions, which doesn't seem, doesn't seem logical when you're thinking of a solid disk or something. But it's a gaseous ball. And we have to remember that there's a difference between a gas and a solid. Just because your hand can knock something and your knuckles get wrapped up by it doesn't make it a solid. There's parts of that sun that are far more dense than gold, but it's still a gas because they're in motion and they're not their electrons aren't locked into in step and valence. But with covalent bonding, it's all motion. It's electrons and protons whirling around each other, kind of like bolo balls.
Yeah. So in this H alpha view, could you explain what these darker regions up here are?
Well, that's the top of a prominence. You're looking at filaments. You're calling them filaments there. Remember, we have a vocabulary that sometimes sounds a little goofy to people, but that's just the top of what you see off the edge there of the prominences. Okay. And once it gets to the edge, how much of it are you going to see? It'd be nice if the whole thing went clear over the disk from our viewpoint, so we could get a huge view, of a big prominence. But those little spikes you're looking at now are just, different angles of them.
Yeah, I'm actually going to try to get the newest image of it from California. Here it is. Okay. So this one was taken at 2037 UTC, so that was a minute ago. So really not too much change in it, right?
Yeah. Yeah, not too much change. If you even go to some of the best solar, find some of the best imagers for solar astronomy, amateur solar astronomy, you'll find a lot of them are digging into their past and showing different views of the sun from long ago. A lot of times what we're trying to do right now is you take a negative image of that star right now and you get a little deeper image than you would otherwise. I can show you an example of it if you can allow me.
Sure.
Here. I can go into my, let's see, desktop, into here, here, and open this one up. And then this is actually a negative image. And it's the only way I can make that star look pretty good. That was actually last June that this was taken. It had a little bit of active region up here and there, and then you get a small filament there. And then I added the false color by using the camera, and then finished this up in AutoStacker. But it's that's just the way that stuff works. At times you gotta play with the camera. Lately it looks a little bit like this was the 22nd. This was taken just 2 days ago. And this is the type of image you're getting. This is not a negative image. This is actually it's positive image. But you see this small filament here, and actually a few days before that, it looked like an arrow. Like you're going off into the twilight zone, that sharp turn to the right or something, which it showed before, but now it's twisted around. And you see that small active region again that you're looking at now, and then a small prom. And it's it's basically just hasn't been let's see if this is the same date, and no, that was before I processed the rest of it, but nonetheless you get the idea that it's very inactive right now, and you're gonna have to use your imagination a lot of times to try to get something that looks somewhat pretty. And okay. And kind of like that one.
Yeah. So probably a lot of viewers, some of the viewers that are watching probably don't understand probably why use H alpha if you could just use white light. What's the difference?
Well, white light, you're not going to get all the details I had of solar flares. You're not going to get prominences. You can pick up granules if you got just the right aperture, and but you can pick up the spots a little bit better, I think, in white light. And you get this region around it called a penumbra, almost like somebody who just got punched in the eye, and all of a sudden this region around their eye gets discolored. That's what the solar that's what you get in white light that you can't get. It's an umbra and a penumbra. One's that's surrounding it, and the umbra is the darker region. The darker region doesn't mean that there's no light there. If you blacked out all the rest of the sunlight, all that means is that there's less density of plasma at that point, and there's less light being given off. It's not. You could still be blinded by that. If you knocked out the rest of the sun, only the sunspot was showing. You would go blind. And it's just that there's its density is the issue there. How much is there?
Yeah, so like me, I use white light. So I'll show you actually a picture I got. This was about when the eclipse happened, back in August. This is like a couple of days before that. 1 second, share my screen. Okay, there we go. So this is on my website. See how we got these small, they're actually pretty big sunspots, correct?
Oh, those are pretty good. Yeah, at the time of the eclipse, it wasn't bad activity at all. In fact, with the white light, you're able to show right there in that photo there, you're able to show those spots better. If I looked up the exact date and looked into my files, I have to look it up, but it's I probably have those, and that the spots didn't show up as well in hydrogen alpha as they do in the white light. Plus, the solar eclipse, you want to take that with a white filter. You don't want to take it with hydrogen alpha. You don't have the effect of the corona.
Well, there are some people who take it with H alpha, correct?
Well, they are, but they won't get the effect of the corona. They already know what they're cheating because they already know what the prominence is there, and here the people get to see it as it as the moon engulfs its shadow engulfs us. So it's.
So here's during the eclipse. I got a picture of the partial, and then you can see that there's that sunspot group. This is a little blurry for some reason. I think it's because the cirrus clouds I had that day of totality, but you can see there's two groups here, and one that's like in a line, which is kind of cool.
Yeah.
So did you see the eclipse?
I didn't. I saw the partial back here. I couldn't make it down there due to a personal situation, so I actually put on a show over at Arlington Heights Library, and I had a crowd of about I forgot how big it was. It was over 500 to 600. But
wow. See, this is my image of totality.
Yeah, the best we saw was about let's say
86.
Right? From totality, go 2 to the left or 2 to the right, and that's about as good as we got. We had 87% hearing.
Yeah, you can show your images now. I got your.
Yeah, yeah, you go. Yeah, we can. There was certainly more active times if we look back into the past. A lot of them, and there was. You'd get prominences. Sometimes you fool around with the colors, and you can even do some things with the camera and cheat by changing, your aspect ratio to make it look. In this picture, it almost looks like you're almost cruising over the sun. And now look how big these prominences look. They look they're more spread out because I'm using a different. If you saw the whole picture of the sun here, it actually looked like an egg. But I did this and did a partial to make it give it a good effect. You got a lot of detail in here, and those prominences came out, I thought, quite well in there. That's June of 2015, And let's see if we got any others here. This is basically the same date. And you're just seeing active regions, the same date again, and far more active regions than you're seeing now, and they're bigger. And this is 2017, and that one not as much. Let's see if I can get down here and get an earlier time. But then there's times when you got to 2016 when you can fool around with the color, and you can produce an image like this. It's a negative image, and I colored in, and you see that these two active regions right in here with the prominence, and then you get a little bit more activity you can see in here with better detail than you could with an actual positive image of the sun that day. It's let's see what else we got. We've got well, you know, at times when I do lunar, I've done that at times. And
so is this processed? All these processed images?
These are not all of them are processed at all. A lot of these were just simply taken. Okay. Some of the ones I showed you earlier here, they weren't processed. They're off the camera. I just set their settings on the camera. So there's actually processing going on in the camera, but anything post-processing, there was none. For example, this one is just a straight shot I took of the moon. And that was with an ETX 125, which isn't a big telescope at all. It's but it gave good images that day. And when you want to get the moon when it's at first quarter, so you can see the terminator, which is right that line right between shadow and darkness. Look how the detail comes out. If this was the full moon, it would look awful. That's you know, difficult to say that, but that's the way it is, you know. But there's just other times, you know, when you're imaging this, or you catch something at right, or you catch part of a situation, like for example, this one of a jet going right across our star, just the tail of it, like that. And there's an exhaust being given off, as you can see, interfering with the image. So it's like we have to use our imagination a little bit more at this time of the with this type of solar cycle than we would at other times. But that's life. Here's let's see, this is January 2016, and that's you know, that's a little bit more like it. You've got to look at how many active regions you've got here, and how many filaments, number of prominences are a little bit popping up here and there, and it's a little bit more like what we would expect. But it's, yeah, a lot of those, if I process any of them, sometimes it's right inside Windows photo editor at the most.
Let's say if one of our viewers wants to take these images of the sun, what would be involved with them? Like, what would you need?
Well, you're going to need first you need a telescope that can look at the sun in hydrogen alpha. It has to have enough. It can't have too much of an aperture, because anything over 6 inches is just a waste of time. It's pretty obvious you're gathering more light the bigger the aperture you have. And when you're dealing with the sun, it's really bright compared to a distant star, which is also bright when you're on top of it, but not certainly from this distance, because light weakens with distance by the inverse square law. Here, it's you get so big, and then you get a blowout after a while. Mm-hmm. So you need a hydrogen alpha telescope, and they can run you into some change, but you gotta have, if you got a hunger for it, then you save your money for it. You know, everybody has their different hobbies. Some of them like to have hot cars when they grow up. Others would rather have, you know, telescopes. And it's that was more my choice in life. But you know, it all depends what you're going after. The sun is active. It changes from one day to the next day. This is 2015. You can see far more activity there than we're seeing right now. And this is 2017, way down. That's 2017. That's 2017. A little bit of activity there, but not a whole lot. This is 2015, and again, and then you're seeing a more active time. That's basically those same dates. And but it's compare the years. It's just way down now. That's 2017. That's then, and then if we go, that should be pictures, and the desktop is the most recent. And recently, we just haven't, 2018 is just hasn't been all that much. The desktop, I had to put them in negative images. Sometimes I can do something like this and try to get part of it looking good. So that's a pretty good prominence right there. It's fairly good. It's 2017 again. That one's just a demo. It's good moonshot.
So, now while we're talking about telescopes, what was your first telescope? Your very first one?
It was the Edmund Scientific 4-inch reflector.
Okay.
It was Newtonian, and it was put on a cast iron mount.
Oh.
And they sold it there, one big package. It was a red telescope. I got a kick out of it. Didn't know how to use it. Didn't know what I was doing. It was at a time, but boy, there was some interesting things going on in the times I had it. And then eventually I got an ETX 90, and during those years I got to see Hale-Bopp go right overhead.
Oh, lucky.
That was incredible. And I saw I caught a couple of grazers going up across the atmosphere of meteorites that just bounce off of that atmosphere and don't come through, but it looked like a turning fireball. That was just beautiful, orange and all these colors it turned. It was just beautiful to watch.
Mm-hmm.
But especially when you're first starting, that's when it's the most exciting. And then you find something you never knew what it was. Saturn, I didn't even know what I was looking at because the rings were on edge that year, the first year. But it's always looking for something new. I think that's what makes us go a little bit farther. Somebody looks at it, aren't you satisfied with just that? Well, no, you get bored with anything, just like we do watching the same TV program 6,000 times. So we look for something a little bit more, and then somebody tempts you a little farther, who took a step farther than you, let's say in our astronomy club. Then you want a little bit more, a little bit more, a little bit more, a little bit more, and it doesn't stop. And it's a fascinating hobby. You meet some interesting people, and the world just seems much smaller than you might realize when other people have been experiencing the very same things. Here's actually the beginning of that big solar flare to let you know how quiet it was at first. And this was right through a cloud, and you can see the clouds passing overhead, and now it's just brightening, and it's just brightening right there.
Mm-hmm.
And that thing would just keep going, and all of a sudden we get about to this, and children were watching this, and they could see it down on the street. I had gone inside. I gave up. I come outside. I pop it to here, and then this is a little bit later. This is and now it's grown, and now there's this like mustache region forming in here. So a little bit more is going on. So we decided we'd take a look at it and see what it looked like a little bit more with a full disk. And then when we did that, it started to look like this at first. And as time goes on, watch how this region starts to change here with time. And then it goes first to here, and it starts to darken. This is material coming at you now. Now, the darker it is, the less dense it is, and now it's being blown out towards us. And this region is getting more. You can almost see motion going on right there in the sun. Things shaking. It's not just the clouds going over, but it's actual activity going on in the sun. Plasma moving around like crazy from the flare. And now we come up to here, And now it's starting to darken in regions, and it's starting to pop here. You go a little farther, and here's the filament they were worried about at the same time. Now you get to here, and now it's become more distorted and more distorted. And by the time you get here, and I got an audience hanging around me now at this time, right in my backyard. And then it became extremely, extremely distorted. This is like a pretty long video that I'm skipping through here to allow your audience to see how it goes. And the darker regions just got darker and darker. This is getting more convoluted all the time right there. You can see it just murmuring around. And then it finished up with the video I showed earlier, which was this one. And that was getting it a close-up. And then it was just, just a beautiful image as long as you're not there. Nice to look at, not a place you want to visit.
Okay, so we're going to go to the next. I have another slide I'll show. This is going to be a coronagraph, current coronagraph.
Yeah.
Once I get it on here. There it is. Can you see it?
Yeah.
Okay, so yeah, this is the current coronagraph. Well, a couple of hours ago. And so why is the corona so important to us at Earth? Why would it what happens if something goes wrong in the corona?
Well, the puzzles are about it. It puzzles astronomers. Professionals get really puzzled by it. It's temperature. Now, astronomers measure temperature a little bit differently than what I first thought of before I got involved with astronomy and had to study it more. It deals with kinetic energies. So when you're getting your thermometer put into your mouth and they're checking your temperature, what happens is the density of the air, the density of the particles, the density of your cells, and the mercury inside the thermometer, once they start to shake, their motions match each other, their kinetic energies. That's when the equilibrium is developed, and that's when the mercury stops moving and it reads your temperature. It's when the shaking is equal. Well, you go up into the corona, and what you have is much less density, but you got a higher temperature. So, strange as it sounds, this Parker Solar Probe, as it goes into there, they've got it set where the temperature will be down to about 87 behind this shade as it starts to enter the corona. But you got to realize if you had this shade in front of you and didn't have it controlled down to that temperature, you'd actually freeze to death in there because the density of the particles is so low. It's like one particle might, the first 300 will miss you and you'll only get hit once in a while. But the trouble is the frequency, the wavelength of that is so short that it'll jiggle around your DNA. And it'll re-radiate, and cascade its way down into other dangerous frequencies that'll radiate the rest of your DNA. And you'll come back with a lot of problems with even flashes in your brains and all kinds of things, and you probably have cancer or something from it. So that it's when they measure temperature, it's not what you feel. It's the kinetic energies of things moving there, and that they can't understand why the temperature is so high there, and yet lower down in the chromosphere and the photosphere. It's only 5-6 kelvins on the 5,000-6,000 kelvins on the in the chromosphere, and yet it's in the millions up there in the corona. It would stand to reason that it should be cooler. And they're trying to figure out why. And they think it might have something to do with magnetic fields, how they're interacting with things, as we're finding out more about how magnetic fields can react with heat and escort heat away. and across maybe there's some properties they have that we haven't understood yet that it's causing this to happen. And future refrigerators, for example, are going to be cooled with magnetic fields, but they haven't got that technology down pat yet. So they're still trying to connect all these things together about magnetic fields and heat. They're not too sure about how it happens. And so they're sending the Parker Solar Probe out there to get some answers.
So the Parker Solar Probe, when is that supposed to be launched?
That left. You know, it was launched. I believe that the day we went to Wildcat Mountain State Park, which would have been August the 11th or 10th, and in that weekend, 11th, 10th, or 12th, it took off. So it's on its way there right now.
Okay.
Yeah. So and it'll be a while before the data all comes in, and but they'll still say eventually it's going to crash right into the sun.
Yeah. So how big is the corona? How far does it stretch? Do you approximately?
Oh, now you're talking enormous. Now, I mean that thing is just like because remember it billows out, and even the magnetosphere of our own planet. If it's defined by the magnetic field, how much of our magnetosphere goes out? We're almost like in a sense, like a comet ourselves, and then our whole solar system is before they can break out there. So it's pretty big, but remember it's thinning out right there. What type of density is it close? It's closer to the sun. It's going to be more dense than it is way out there past Pluto's orbit, but just right there by the sun, that you got enough of it to define it as we'll call it a corona.
Yeah, and the problem is scientists can't see the inner corona with a coronagraph, so they have to see a total solar eclipse, right?
Yeah, it's easiest. You gotta block out the sun if you want to get a good detailed image of it. That's the best we can do right now. It's not that something. Hydrogen alpha will not pick that up.
Yep.
The only time it'll pick it up is if I'm watching a filament on the star and you just see the thing pulled right off. Then one happened, but you didn't actually see the coronal mass ejection itself.
Yeah, so like in this picture, you can see there's totality. This is the inner corona, and then the outer corona stretching out there, right?
Yeah.
So yeah, that white part, if you were at the eclipse and you saw that white part, that is the corona Bob has been talking about. So another question. So let's just stray away from talking about the sun for a second. What is your favorite deep sky object to observe?
I would say probably M17, the Swan Nebula. It looks like a swan to a lot of people. To me, it looks like a chicken on a rotisserie.
Yeah, I was looking at it at Wildcat. Man, it looks great there.
Yeah, it looks beautiful. Even in an eyepiece, it looks good. But although it doesn't look like that, but if you saw it, an image of it, it's that was my impression of it when I first saw it. I thought, holy smoke, that thing looks like a chicken.
Well, personally, I see a swan, but maybe it is
okay. Yeah, well, remember, my eyes aren't that good.
Some people see omega too, So
yeah, oh yeah.
And then another question. When did you start solar observing?
One of our club members, he was involved with solar observing, and he had one, and the way he talked about the sun. This was when I was right in the beginning. He said it's so dynamic, it changes all the time. He says, I have trouble finding deep sky objects and all that. I'm looking for all night long. The sun, I can just work on one thing. I can find that. And so that got me interested. When I looked through his telescope, he had a 90 millimeter, and it was Coronado, and it was a beautiful image, and I thought it was so pretty to look at it like that. And I wanted to get a telescope and enjoy it the most I can. So the more I looked, the more I wanted to look, and the more I wanted to get out of it. And I'm still got the hunger to go after the sun more and more.
Yeah, so people who don't know, Bob is actually the president of the Northwest Suburban Astronomers, which is an astronomy club that is centered in the northwest suburbs of Chicago. So, is there anything you'd like to say about that, Bob?
Well, we reach out to the public sometimes. A lot of times, they're the ones that find us. And you're one example. You came, and a lot of times I think we go fishing. We go out there and we put out a bait, and all of a sudden there's somebody that really wants us, and was looking for it. Who was hungry to begin with. They've heard about us. They read about us. We advertise we're going to be at a place, and they're there, and they come after us. And you were one. Mm-hmm. And we get a lot of our new members that way. I was looking for the club when I first joined. They didn't go looking for me. A lot of hobbies that way. Yeah.
So, we're talking about solar observing. So actually this Sunday, right? This Sunday, we're having a solar observing for the Northwest Suburban Astronomers from, I believe, 12 to 3. Correct?
That sounds good. That sounds pretty accurate. 12 to 3 at Stillman Nature Center in Barrington and South Barrington. And it's enjoyable to go out there, and by Stillman Nature Center, they have so many things there. They have falcons. They have a wonderful place to hike through. You bring binoculars to look at. There's all kinds of things in the pond there, turtles going around, and we just look at anything flying over, and sometimes hawks going in, or they're stalking some prey or something. But it's a wonderful nature walk. It's a picnic. It's a potluck, so we're bringing food and sharing things like that. But it's an annual event. It's supposed to be pretty hot that day. It should be in the 90s.
But it'll be mostly sunny, so that's good.
Yeah, there'll be that, but I won't be doing any video that day. I'll just bring the scope, put it up, take a look at it, and that'll be that.
Yeah.
It looks like an eyepiece that day.
Yeah. So if you want more information, visit www.nsaclub.org/events, and then you can look there and get more information. So, is there anything else you'd like to say, Bob?
Well, in terms of Stillman Nature, don't forget the food. Bring some.
Yep.
We enjoy that.
Okay, so we'll wrap it up in about a minute. So, thanks, Bob, for coming on.
Well, thank you, Tyler, for having me. It was a pleasure talking with you.
So if you would like to see Bob's videos, it's Drake Equation 521, right?
Yeah, you can see them on YouTube, and you'll actually see some of the ones I showed right there. And there's a couple others where I was just doing some testing, and I think some cirrus clouds were passing over. I didn't put too many up there. I might be putting up some in the future. But there's another place I go to also on Facebook. It's called the Solar Activity Group. If you look that up with Pam Shivik, and you can, if you're on Facebook, you go there and you'll see some incredible images, especially by Gabriel Corbin. He just mind-boggling what he can do with his the equipment he has and what he does in processing. Just incredible. But anyway, and there's a lot of good imagers there as well besides him. So, yeah, there's plenty out there, but it is good being with you.
Yep. Also, don't forget that this Sunday I will be doing another live stream at 9 p.m. of the moon and then the planets, as there will be a full moon on Sunday. Hopefully, it will clear up. I don't know for sure if it's going to be clear on Sunday night, but if it is, we'll be live streaming, just me And, well, guys, thanks for watching. Thanks again, Bob.
Thank you.